Okay, in today's lesson, we're going to continue our work with the different types of angles that we talked about in the last lesson. You can see our learning target is just simply, I can prove that two lines are parallel using the angles formed by a transversal. So all those pairs that we learned about in the last lesson, somehow relationships among those will get us parallel lines. So let's start with the first one, which I think is probably the most common. If I have two lines, let's go back to my pink transversal here. If I have two lines and a transversal, if I mark these two angles, hopefully you see that those are alternate interior angles. If those angles are congruent, then I know the lines are parallel. So we're going to simply state it as this. If alternate interior angles congruent, then the lines are parallel. So in the last lesson, we were just identifying them. Now we're actually going to say they're congruent. That implies something. All right, so if I draw another set of lines and I put a transversal in again, and this time I mark this pair, hopefully you can identify those as alternate exterior. If, again, they are congruent, then the lines are parallel. So if alternate exterior angles are congruent, then the two lines would be parallel. Okay? We mark parallel, by the way, with these little arrow symbols, or you could put a double arrow symbol if you have more than one set of parallel lines. So that's how we say they're parallel. All right, so we had alternate interior, we had alternate exterior. If you remember, we also had this type. See if you remember your vocabulary. If I mark the top left and the top left by each one of these vertexes, right? If they're in the same positions, we call those corresponding angles. If those are congruent, we also can say the lines are parallel. So if corresponding angles are congruent, then the lines are parallel. Don't confuse these type of corresponding angles with the kind of corresponding angles we say when triangles are congruent. These are corresponding angles for these parallel lines. So again, top left and top left corresponding. All right, we had another set of pairs. So we had the two alternate interior, alternate exterior. We had corresponding. And then if you remember, we had kind of another set. We had same side interiors and same side exteriors. So let's look at that for a minute. And let me put in kind of a more interesting transversal. I hope you can see that when I mark a pair of same side interiors, I hope you realize that those aren't going to be congruent. Right? You can see that they definitely are not the same size. But the trick to getting parallel lines from same side interiors is that they have to be supplementary. So if same side interior angles are sup, then the lines are parallel. And similarly, we can do that for exterior, right? Same side exterior, which would be this angle and this angle. If same, I'm going to underline that, side exterior angle sup, then parallel. All right, and you might say, well, why do we have an extra box? Because we've already used up the 5 types we had. There's one additional one that I think you can see is kind of a special case if I draw it out for you. If I have two lines and I put a transversal in, and I know that this is perpendicular, and perpendicular means forms right angles, and I know this is perpendicular right here, forms right angles. I hope you can see that they'd be parallel, because if these are both 90, that actually satisfies same side interior being supplementary. If these are both 90, they'd be congruent. That would be alternate interior congruent. So really, this is a special case of a lot of these that we've already talked about. But we call it a separate one because sometimes it comes in handy, and we say if two lines are perpendicular to the same line, then the lines are parallel. So we're saying we have perpendicular here and we have perpendicular here, then those lines would be parallel. And we don't use that one as often, but again, it's kind of a special case. You can get around it by just using those right angles and saying same side interiors are sup or alternate interiors are congruent, etc. All right, let's actually try some proofs. Okay, so in your packets, there's a typo here, I believe. So go ahead and change this letter right here to a D. So in the given, we have AB and DC bisect each other at E. So remember, bisect means to cut in half or cut into two congruent segments, and they bisect each other. So if AB gets cut in half at E, shouldn't that mean that AE is congruent to EB? I'm just building off of the given. But it said they bisect each other, so that means DC also gets cut in half at E, which means CE is congruent to DE. Now we're going to say if segment is bisected, then it's divided into two congruent segs. Well, from the last chapter, you should definitely be leaning towards congruent triangles. Remember, one of the things you have to see in the diagram is this pair of angles. I hope you know why they're congruent. Angle CEB is congruent to angle DEA because those are vertical angles. So if vertical angles, then congruent. And I hope you can see my triangles would easily be congruent. So it looks a lot like what we did in the last chapter, but I'm trying to prove parallel lines. So let's think about that for a minute. Here's what I'm trying to prove. All right, I like to use a lot of color in this chapter. I need AD parallel to CB. So we know in order to prove parallel lines, I have to have a pair of those angles that we mentioned on the previous page. To get a pair of angles, I need a transversal. I can actually pick either transversal. I have CD or I have BA. I'm just going to highlight BA. And I hope if I highlight BA, you see a letter jumping out at you. It is a Z, right? A Z we associate with alternate interior angles. So if I could get angle B congruent to angle A, that would be a pair of alternate interior angles congruent, and then I could say my lines are parallel. Well, you should all know now why angle B is congruent to angle A. Aren't those corresponding parts of my triangles, right? B corresponds to A. So I'll say angle B congruent to angle A from my triangles. If triangles congruent, then corresponding parts are congruent. So I'm going to go ahead and mark those angles. And now I can see they make that Z for these parallel lines. So now I can say AD is parallel to CB if alternate interior angles are congruent, then the lines are parallel. So the toughest part of this, the congruent triangle part you'll be comfortable with, it's going to be choosing the correct corresponding part. What do I pick? Specifically, what angle pairs do I pick to help me get a set of parallel lines? And often highlighting the parallel lines in the transversal will help you see which angle pairs you need. All right, so let's do this one right here. AP congruent to AQ. We're just going to do two more today. BP congruent to BQ, BX congruent to BY, CX congruent to CY. That's all given. Let's mark that. AP, AQ, BX, BY, BP, BQ, and CX and CY. So hopefully you're taken back to the beginning of this chapter. If I cover up part of the picture, right, I see these congruent pairs. This leads me to believe that A is equidistant from P and Q because the distance from A to P and the distance from A to Q are the same. I would also argue that point B is equidistant from P and Q because this distance matches this distance. So if 2 points are equidistant from the endpoints of the segment, don't they form the perpendicular bisector? So I can say that line BA is the perpendicular bisector of PQ if 2 points equidistant, then perpendicular bisector. If I cover up this part of the picture, though, you should see the same thing. Isn't C equidistant from X and Y? What other point is equidistant from X and Y? Isn't it B? So therefore, the line BC should be the perpendicular bisector of XY. So I can say line BC is the perpendicular bisector of XY. I'm actually not even going to make that a separate statement. That's all by the same reason. All right. Now, what do you notice about BA and BC? Line BA and line BC. Hopefully you realize when you look at the diagram, they are the exact same line. These, right here, are the same. So we have two different segments that are perpendicular to the same line. So this is perpendicular, and this is perpendicular. Are you thinking of that special case? If I flip back and show you here, right, do you remember this one right here? If two lines are perpendicular to the same line, then they are parallel. I believe that's what we have, right? We have these two that are perpendicular to the same line. Therefore, these two must be parallel. So there's a nice application of that example. If two lines are perpendicular to the same line, then they're parallel. All right, one more example here. Let me get on the screen. We have KJ congruent to MJ. Let's mark that. Okay, when I mark that, I'm looking at this big triangle and thinking isosceles. GJ congruent to HJ. Well, when I mark those two, I'm thinking of the little triangle being isosceles. And I have HGJ congruent to HMK. HGJ, that's this angle. Mark these carefully. HMK is this angle. Okay. I'm going to get what I can from the given and then look at what parallel lines I want. Let's see what I've got here. Let's go back to this big triangle. I marked these two congruent first. We said this big guy is isosceles. So if sides, then angles. So wouldn't those two angles be congruent? So I would have angle HMK, that's this guy right here, congruent to MKG. But if this little guy is isosceles, shouldn't these two angles be congruent? That would be angle HGJ is congruent to this one on top here, JHG. That's by if sides, then angles. If you were marking it on your diagram, you should have noticed that we double tagged some angles. When we double tag angles, you should be thinking of transitive, right? And you can see the connections right here. Here's HMK and here's HGJ, right? So if JHG matches HJG, HJG matches HMK, HMK matches MKG. So the two that are not double tagged, I can now hook up. So I can say this angle is congruent to this angle, or any of the ones I want congruent. Well, the question is, which ones do I want congruent? If I can now hook them all up by transitive, which ones do I want? Let's see, GH and KM. There's the two lines. Now I need a transversal. Well, which transversal do I want? I could either take the one at the top or the one at the bottom. So I'm just going to take the one at the bottom. If I mark that transversal in, I hope you see an alphabet letter there. It's kind of backwards, but hopefully you see an F. An F makes corresponding angles. That would be these two right here. right? This would be in the top left. This would be in the top left. So those are the two that I want congruent by transitive. That's the HGJ, and that's this one down here. That's the MKG. So that's these two. And we knew we could hook them all up via transitive. Okay, now that these two angles are congruent, right, those are corresponding angles for these lines, so now I can say GH is parallel to KM if corresponding angles are congruent, then the lines are parallel. We'll practice the other two examples in the next video.